Whenever it looks like this, it's said to be in standard form. In other words, you have to have a 1 here. That's the goal. Okay, so if you have like an x here, you have to divide by it, right? So you got to get rid of whatever is there. That's the thing, right? Okay, so this is a linear equation. I used to go through the derivation for this. It takes like 15 minutes, but it's really confusing. I mean, you can take pictures of my notes. It's there, so if you really want to read it. And it doesn't really help you on the test. So I'm just going to give you the steps, like step 1, step 2, step 3, step 4. And then we're carefully going to do some problems, like really, really slowly, because this is very new. So steps. Wait, this is the whole section, right? Once you know this, you know the whole section. It's the nice thing about this class. It's like, this is what you do, this is the whole section, we're done. It's beautiful. 1. Step 1 is to make sure it looks like this. So if there was like an x, so if you had like x squared dy dx plus some stuff, you would have to divide by x squared, right? Okay, very key. So write in standard form, write in standard form. So in standard form. Standard form. Okay, so that's step 1. Step 1. Step 1. Oh wow, interesting. Step 2. I hadn't looked at my notes. I haven't looked at them since last semester too. We have to compute something special. Okay, we have to compute, and maybe it's a new Greek letter for you. It's mu of x equals, and that's going to be e to the big integral of big P. Okay, so compute mu of x. It's e to the integral of big P. Let me write that again so it's easier to see. The integral of big P of x with respect to x. Okay, that's called the integrating factor. Okay, this is called the integrating factor. So compute the integrating factor. If you're wondering where this comes from, it comes from the derivation. Okay, I can explain the derivation when we do an actual problem. It's really like easy to explain in a sense. So mu is a Greek letter, right? It looks like an M. It looks like a U, so they call it mu. I don't know if that's why, but that makes sense, right? It's mu. Sometimes I'll do this, mu, they have tails on them. If it's typed, it's like a fat mu. It's like, but I do this. Okay, so mu. 3. This is tricky sometimes, right? You have some, not super hard, but careful integrals. We're going to be very careful when we compute this. Multiply by mu of x. Multiply the dE by mu of x. Okay, so you multiply the entire dE, the one in standard form, right, by your integrating factor. So make sure there's a 1 here. You have your p. You compute this integral. Carefully simplify it. You're allowed to skip steps. I wouldn't. And then step 4. Step 4 is to finish. So finish. Finish. I'll show you. I'll just show you. It's too many steps. It's ridiculous. I will show you. I'm just going to show you. I'm just going to do a problem. Right? It's really tricky, the finish part. That's the hard part, actually. So why am I not writing anything down? I don't know, but I think it's better if I show you. All the ones in the homework are pretty reasonable. What is going on there? Okay, what is that? Oh, that's not an example. That's an example. Let me find one from the homework. I have all the homework worked out so I can see how hard they are, which is really beneficial. It's like, oh, I want to pick one that's like, what is that? Okay. Yeah, okay. Let's do number 3 from the homework. Let me find it. So 2.3, number 3. Yeah, let's do a homework problem. So number 3. Number 3. So number 3 from the homework is, so it's x squared y prime. So x squared y prime plus, anyone have the homework up? What is the rest of number 3? X squared y prime.
X squared y prime plus xy equals 8.
Equals 8. Okay, thank you. Jennifer. No. What is it? Nikki. Okay, I thought it was a J. Okay, sorry. Thank you. Great, Nikki. So solve. Okay, so this is our DE, right? This is our DE. It wants the answer. It also wants the largest interval over which the solution is defined, and it also wants what's called the transient terms. I'm not going to ask you any of that on the test, but I'll show you how to find it. On the test, it'll just say solve, okay? So first step is we have to write this in standard form. So what should we do first?
Get rid of that x squared.
Good, yes, get rid of the x squared, yes. So first step, you do this. And you know, if you're taking a test and you know it's linear, already you're ahead. Like, that's huge, right? So you can tell it's linear because it has that form, right? It's like y prime, some stuff times y, equals some stuff with x, right? So it's like you have the y prime and the y, right? That's how you know it's linear. So if you know what it is, if you know what type of DE it is, and you take the right approach, that's huge, right? That's huge. Okay, so that was step one. That was step one. Step two is to to compute the integrating factor. So the integrating factor is e to the integral of big P. So big P, what is big P in this problem? 1 over x, yeah. So let's do it. So mu of x, I'm gonna write a little bit bigger. I was thinking about the room because the finished part is really tricky. So it's e to the integral of 1 over x dx. And I'm gonna show like a painful number of steps here, but you're allowed to skip them on the test. This is where you're usually going to get some of the answers in the homework, like the interval part of the question will usually come from here. It's about to happen. I'll show you. 1 over x turns into e to the ln. And what goes around the x? Absolute value. It's very important for the homework. Yep, in order for the understanding part. Don't worry about the plus c. Right? If you do put a plus c, it's like before, it becomes like, you know, if it becomes this, then you can break it up, and you're going to end up multiplying by this anyways, so you can divide by that constant, and it doesn't matter. These will cancel, and so you're left with the absolute value of x, right? So we're actually left with, now we're going to strategically get rid of the absolute value. If you're wondering how, we're just going to cheat. So, so I don't know if you know this, but the absolute value of x is equal to a piecewise function, right? It's equal to x if x is greater than or equal to 0, right? And it's equal to minus x if x is less than 0, right? This is a definition that is often used a lot in advanced calculus, actually, and in some harder Calc 2 problems and some harder Calc 1 problems, and some of the harder ones, right? But it's not something you see all the time. But this is the definition of absolute value. So we have to pick which one to use. You could pick the negative one. It will work, right? If you pick the negative one, you just get negative x, and you multiply the whole thing by negative x. But then you can divide by negative 1, and that becomes x. So let's just always take the positive one. So this is equal to x. But this is true only if x is greater than or equal to 0. Actually, x can't be 0, right? Because we have an ln here. So it actually has to be x what? X greater than 0. Good. Also, look, we divided by x here. You see that? So x can't be 0. It's really important for the interval part in the homework, okay? The good news is a lot of times it's multiple choice. So you have 30 tries. And so, okay. So mu of x is equal to x. So mu of x is equal to x. I'm going to put this in a box here. This is important. On a test, you don't have to show me this, right? I don't care. I just want the answer. It'll just say solve, right? So I'm not going to ask you for the other stuff that's in the homework. All right, so we're here. Next step is to multiply everything by the integrating factor. So we're multiplying this one, right? So it'll be x y prime. Let me write that down. Multiply the DE by mu of x equals x. Let me just throw that out there. Why not? Just so you have it. I mean, I could have just done it, but I don't know. I've never written that down before. First time ever. So I don't know if it was worth it. Okay. xy prime, right? So xy prime. What happens here when you multiply by x? What happens to the x's? They cancel out. Very good, Kyle. Right, Kyle? Oh, you are wearing a name tag? That's so cool. It's like a Viking name. Okay, then x times 8 over x squared. So they can, it just sounds like, I don't know. I must have seen a movie or something like Kyle's the Viking. I don't know. So we're here. Any questions so far on this one, on the steps on this problem? So now you're supposed to finish. Yeah.
At this point, would it be improper to multiply by absolute value of x?
It would make it more complicated, right? Because we multiply by x just to get rid of the absolute value. So you have to pick one. Mm-hmm. You have to pick either x or negative x. Good question. All right, so here's the trick. Yeah.
Where does the square go?
Oh, okay, so good. Multiply by x. Multiply by x, what happens? It cancels. And then multiply by x, goes away. No, worth it. What's your name? Mike. Mike. Good question, Mike. Yep. Any other questions up to here? The next step is extremely tricky for people to understand, I think. So it takes a couple tries, like a couple problems. All right, this is magic. This is always going to be equal to this. Watch this. It's always this. It's always d. All of this is a derivative. It's a product rule derivative. It's always going to be your integrating factor, which is x, times your unknown function. In this case, our unknown function is y. Always. So I should write that. So it's always, it is always d dx mu of x. I'm going to put a y here, but this is a bit sloppy because sometimes the unknown function is r, or sometimes it's like some other letter, right? So just keep that in mind. But it's always going to be mu of x times your function. You can check your work. Let's check our work. I don't know if you all remember the product rule. I'll refresh your memory. This is how I do it. I think of it as first and second, okay? So it's the derivative of the first times the second plus the first times the derivative of the second. So that's the derivative of the first times the second plus the first times the derivative of the second. So here's the derivative of the first, which is 1 times the second plus the first times the derivative of the second. You see it? Derivative of the first times the second plus the first times the derivative of the second. You see it? Does everyone see it? You see it? You see the product rule? It'll always work. Okay, so you can check your work on the test, and this will always happen. If you're wondering why this happens, it's rigged, right? If you look at the construction of this, forces it. They take a general linear equation, they multiply it by mu of x, and they solve for mu of x, and they get the ridiculous formula with the e and the p, right? So this is a creation, right? It's all human-made. All math is human-made, but this specifically seems really contrived, right? It'll always work, okay? So from here to here, it's always mu times your y. How do you get rid of a derivative? Oh, someone asked this earlier. What's the opposite of differentiation? Integration. So don't put the integral sign here, because if you do this, you're missing the dx, and I'll have to like take off a point. That's no fun, right? So what I usually do is I just write integrate. Or just do it. When you integrate this, you just get xy. Usually the integrals are really easy. Integrating this, what type of function is this going to be? 8 over x. ln, very good. It's 8 ln, absolute value of x. I'm just going to go with c, because the y is over here, so we're going to be good. I'm doing good on time. We'll have time for one more problem, which is totally important to do. Almost done, right? We're almost done. Last thing to do to solve for y would be what in this case? Divide by x, yeah. So most of these are explicit. I'm going to divide each piece by x because that'll be beneficial for the homework. So it'll be 8 ln x over x plus c over x. Boom. That's the solution. Yes?
Could we still call c over x just c, or now that it has over x, does it still have to be called c over x?
Yes, because x is a variable, not a constant. Good. Ryan. Yes. If it was like c over 2, then you can rename it. Good. Good stuff. Good stuff. Any questions? Questions? Does it make sense? No? It doesn't? This part here?
A little bit, yeah.
Yeah. Let me go over it again, then we'll do another one.
It's just the whole time I'm just sitting here going, why?
Why? Yeah, oh, why this?
Why?
Y-
What is this? What do we end up using this for?
Oh, DEs?
Yeah.
Oh, to like model things. Like the extra credit problem, the zombie virus.
Okay.
Like to figure out like how many people do get infected, like, should you leave the school? No, I'm kidding. No, it's used to model things in physics mainly and stuff like that. So first thing you do is divide by x squared, right? So that puts you here, right? So you're here. At this point, you have to compute your integrating factor. So your big P is always this here. Then you compute e to the integral of big P. Be really careful here when you drop the absolute value. You have a choice, right? You can put x or you can put negative x, but make a decision because you need one. I always just use the positive one. This is important. We're about to use this. Then you take this and you multiply this by x. So it's xy prime. Boom, there it is, xy prime. And then it's x times 1 over x. That cancels. Boom, there it is. 8 times this. The x's cancel. There it is. This always will become the derivative of your mu, which is x, times your unknown function. And you can check the derivative of the first is 1 times the second plus the first times the derivative of the second, right? Always, every single time. Then you just integrate. Don't write the integral sign because you might mess up. This goes away, integrate this, you get this, divide by y, and there's the answer. The homework wants something called transient terms. Any questions in the process, on the solving process? Okay, the homework wants something called transient terms. This is not on the test, or it won't be. So the transient terms, you have to enter them in a comma-separated list, are the terms that approach 0 when x goes to infinity, right? So basically, just take the limit, right? So this is going to approach 0 because x grows faster than the natural log of x. So this will approach 0. So this is the transient term. So one of the transient terms is that. Likewise, when x approaches infinity, this approaches 0. So this is a transient term. As x approaches infinity, the entire solution approaches y. So you can think of all of the solutions approaching y as x goes to infinity, right? Because you have a solution curve. There's infinitely many solutions. And as x gets really, really, really big, they all get closer to y equals 0 in this case, right? So you just look at each piece and ask yourself, what happens when x goes to infinity? So, the interval of definition, I'll call it I, usually comes from here. So basically, for what values of x is the solution defined? Well, positive x, right? So it'll be 0 to infinity. So 0 to infinity. That's called the interval of definition. So, and it always will come from here, okay? From here. This is the tricky part where it'll come from. We have like 10 minutes. I think we can squeeze in another one. We should do another one. We should do another one. Any questions on this one? Any questions? This step is a bit weird, right? I think that's the weird step. Yeah. Let's see if I can find one that's better to do. What's that? Maybe we should just do that one. Yeah, maybe we should just do. Yeah, let's just do it. Let's just do number 7. Let's just do it. Number 7. Number 7. 7's got some trig functions in it. I feel like we did it, but maybe this is wrong. It was. Yeah, I couldn't. That's not possible. Cosine x dy dx plus sine xy equals 1. So plus sine xy. Really nice test question. All of these are, right? Once you do like 2 or 3 of these on your own, you got it. It just takes. You have to actually learn how to do it. What's the first step in this problem? What should we do? Divide by cosine x. Very good. What? I thought it was divide by cosine x. Michelle. Michelle. Very good, Michelle. Michelle is right. Michelle said to divide by. I keep saying it. Divide by cosine x. Boom. There it is. So you have dy dx plus. What trig function is this? What is it? Tangent, yeah, tangent, good stuff, tangent. All right, it already feels easier because it's the second time, like it's, ooh, what about 1 over cosine? Secant, yes, the evil secant function. Yes, yes. So divide by cosine. Divide by cosine, so you get sine over cosine, which is tangent. Divide by cosine, so you get 1 over cosine, which is the evil secant function.
Yeah, I know. Why is it evil?
I don't know, because it's really, I don't know. I had a student once from Russia, and he said that in his country they didn't use these. I don't know if that's true. He was like, in my country we do not have secant and cosecant. Yeah, that's how he talked. It was awesome, but he withdrew. He had all of the formulas for like the derivatives memorized in terms of sine and cosine. Like you know how the derivative of secant is secant tangent? He had it memorized another way. So hardcore, right? Okay, now we have to compute mu of x, right? Mu of x. Do you remember what it was called? I had a name. Do you remember the something factor? Do you remember the integrating factor? Yeah, it's a common thing in DE. There's all kinds of problems where you have like integrating factors. Usually they're not so fun. These are a little bit better. These I like these. That's e to the integral of big P. What's the big P in this problem? Tangent, yes, tangent x. Tangent x dx. And this is where things might get a little bit weird because you might not know this. So I can assume that you know it, so if you just write the answer down, I'm good with it. If you don't know it, you can memorize it or you can do it really quickly. I'm going to show you how to do it super fast. It's sine over cosine. Then you let u be cosine, go really fast. And then you do this. I wasn't going to do the whole thing. And then this becomes negative du over u. So you get negative ln absolute value cosine x plus c. So you can do this in your head if you think about it like this. Tangent is sine over cosine, right? So the bottom is your u. So you're going to get 1 over u, so you're going to get ln cosine, right? Because it's sine over cosine. So you're going to get ln cosine. And the derivative of cosine is negative. So this is negative ln cosine. Right, because the cosine's on the bottom, right? So that's how you know it's ln cosine. That's how I do it. I just think about it in my head like, oh, it's sine over cosine. So what if it was cotangent, right? If it was cotangent, it would be what? Ln, what do you think? Sine, that means you get it, yes. That's like a higher level of thought, good. Because if it's cotangent, it's cosine over sine, right? And then the u is sine, so yeah, I used to hate memorizing these because I teach Calc 1 also, so I'm like, oh, I don't want to memorize this. So I try to like memorize it with the least amount of work possible.
In this integral, are we always going to have a function that is 1 over to get?
Not always, but it seems common, doesn't it? Yeah. On their final last semester, they had a secant here. It was integral of secant x. So they had to know that one. Okay, we have like 5 minutes. Oh, we can't get rid of this yet. This negative has to come up, right? Power rule. This is going to seem weird. It's ln secant. You might say, what happened? Confusing. Yeah. So it's like I don't even know. No. So we have this. It's like I don't even know what happened. No. So I do. So we have this, and then the power rule says that you bring it up. So it becomes this. It becomes this. Yeah. Then it's 1 over cosine, which is secant. Right, you can do that with the numbers. You can bring them up. They become exponents, right, and logs. Remember, like if you have 2 ln x, that's ln x squared. Yeah, you get really good at math in this class, like really good. Like by the time you're done with this class, you're a warrior. Yes?
The absolute value doesn't interfere with that at all?
No, it doesn't. That's a good question. That's a really good question. Yeah, you become a math warrior. Yeah, there should be shirts. Math warrior. So now these cancel, so you get absolute value of secant. Oh, why did I pick this one? I picked a hard one. Okay, all right, we got this. So we want it to be positive because that's what we always want because that's how we are. So we want it to be positive just to get rid of the negative, right? So when is that going to be positive? We could do that really quickly. Secant is 1 over what function? Cosine. So the question is really, when is cosine positive? Well, the graph of cosine looks like this. This is a terrible graph. And this is negative pi over 2, and this is pi over 2. So one such place would be here, from negative pi over 2 to pi over 2. So this means that x is in negative pi. There's other intervals, but the homework I think just wants 1. So this is going to be our I. Okay, this is going to be the I. This is the answer for I. Okay, so it's multiple choice in the homework because you have to really think here, right? Secant is positive, secant is 1 over cosine. When is cosine positive? You have to think about the graph. Oh, you can also think about the unit circle, right? Oh, didn't even think about that, right? On the unit circle, right? Check it out. Oh, yeah, it works. Because cosine is the x-coordinate on the unit circle, right? So the x-coordinate is positive here and here. Oh, look. So negative pi over 2 to pi over 2. I just figured that out. So yeah, didn't think about it that way. So multiple ways to do it. All right, next step is we take the secant and we multiply our dE by secant. So it'll be secant times this, secant times this, secant times this. Let's do it. So it'll be secant x dy dx plus, so have 2 minutes. Secant x times tangent x, secant x, tangent x, y equals, and what's going to be here? What's going to go here? Secant what? Secant squared! Yes, secant squared! Good. Good stuff. Good stuff. And then this always will magically become d dx. And let's see, it's always going to be our unknown function, which is y. I'll put that one first this time. And then, what was our integrating factor in this case? Secant. And this is secant squared x. It's always that, okay? It always should be. I haven't even checked it yet. Why? Because I haven't thought about it yet. But I should probably think about it because we have 30 seconds. The derivative of the first times the second plus the first times the derivative of secant, which is secant tangent. So it checks. How do you get rid of the d dx? What do you do to both sides? Integrate. So we get y times secant equals, integrating secant squared, you get tangent, right? Because the derivative of tangent is secant squared. I'm going to add a c here. The last thing to do would be to divide by secant. To make it a bit easier, I'm going to write it like this. It's a trick. Okay, this is just a trick to make our lives easier. And then multiply by cosine, right? So how do I know to do this? Because I've done it before. So, and that is the final answer. So you could have divided by secant, but I did not, in the time we have, because class is over, we're out of time, I didn't want to have to simplify tangent over secant because it takes like 3 minutes. So I thought, let me write it in terms of sine and cosine, multiply by cosine, and you get here. There's no transient terms in this problem because nothing goes to 0 when x goes to infinity, right? You can't, it doesn't, these are wave functions, right? So that will not happen. So, any questions on this stuff? Any questions on this one? We finished it. We barely did it, but we did it. Anyone like this stuff? Anyone like the linear DEs? Good. Extra credit. No, I'm kidding. No, you don't need it. So try to do homework, right? If you can finish 2-2 and 2-3 before next time, that's amazing. You don't have to, but like, wow. So am I correct? And is it D?
R over d theta. R secant theta equals cosine.
Oh, plus R secant theta.
Equals cosine.
Thank you. Perfect. And so we have to solve this for R. Right? We have to solve this for R. R is the unknown function we have to solve for. So you can tell it's linear because you have like your dr d theta and you have your r here, right? They're both to the first power. It has that form, that linear form. So the first thing you do when it's linear is you make sure this is a 1, so that's okay, right? So we're there. The second thing is you compute your mu of theta in this case. That was called the integrating factor, right? Hey! Mu of theta. And that's equal to e to the integral of big P. This will be e to the integral, and then big P is whatever is next to your r. So it'll just be secant theta, right? So we're here. So secant theta d theta. So first First step is always just to compute that. So whatever is there is your big P. And this is where I think last semester on the final, a bunch of people got really stuck because they forgot the integral of secant, right? Which is okay, but you won't forget. So it's E. Anyone know what it is? Anyone? It has a secant and a tangent. What else does it have? It has an ln. Yes. And it's secant theta plus tangent theta. Whoops. Plus tangent theta. So that's the integral of secant. Right, that's the integral of secant. Do you all remember that from somewhere, maybe? It's okay if you don't. The reason I'm doing this is because I figured you wouldn't, right? So now you know, right? So this is one of the ones you eventually end up memorizing in this class, right? If you don't already know it. So the integral of secant is ln absolute value secant plus tangent, right? So it's a good one to know. At this point, the e and the ln cancel, right? They go away. So you're just left with the absolute value of secant plus tangent, right? Plus tangent of theta. So we're here. Absolute value of secant plus tangent, right? Plus tangent. And now we can drop the absolute value, assuming everything is positive, right? I think we talked about that before. So I'll just say this is equal to secant theta plus tangent theta, and we'll make the assumption that this is positive. So I'm going to write it up here. So this is if secant theta plus tangent theta is greater than 0. So in general, you can always just drop it and make sure it's positive, right? You can just assume that it's going to be positive. This is where you get your interval of definition for the homework, right? And so keep that in mind. On the test, though, I'm not going to ask for that, so don't worry about it, right? Just drop the absolute value and go with it. I guess we could figure this out, or we could come back and do this later. I say let's figure it out later. Let's wait to the end of the problem. So let's just keep going. So I'm going to write it again. So we have it here. So mu of theta is equal to secant theta plus tangent theta. Secant theta plus tangent theta. Good stuff. Good stuff. Secant theta plus tangent theta. So that's our integrating factor, right? Integrating factor. So it's e to the integral of big P. Any questions? Any questions? We have time, I think. So we're doing good on time. Questions? All right. So now we have to multiply everything by mu, right? We have to multiply everything by this. So you multiply this one, right? So we're just going to put a secant plus tangent here, a secant plus tangent here, and a secant plus tangent here. Okay, so I'll write it. So it'll be secant theta plus tangent theta times, and then dr d theta. Haven't done this problem in a while. Plus. And then you do it again, right? You just put it here, right? Multiplying the whole equation by the integrating factor. So secant theta plus tangent theta. And then we have r secant theta. Gotta be careful here. I think I messed up last semester when I did this problem. And then secant plus tangent times cosine. So secant theta plus tangent theta times the cosine of theta. I'll pause here and let you catch. It looks ridiculous, right? It looks completely ridiculous. But it's not too bad. It's not too bad. Does anything cancel, you think? Over here, right, some stuff is going to cancel. Yeah, I think last semester I was doing this one in class and I canceled wrong. And I messed up like twice and it was just horrible. But I won't mess up. So, have I lost any points in this? Have I made any mistakes?
Yeah.
I have? Really? Yeah, well, that's not going to happen again. No, it's not. It's on. I slept like 10 hours. I'm good. I'm not going to mess up. I was in bed by 9. I was asleep by 9, so I'm good. I'm not going to mess up.
I think every time you say it, we all become more hyper-aware.
No, it's not going to happen. All right, so I made a bunch of mistakes yesterday, but I was subbing for another teacher, so it didn't count. I was like, oh. Someone's like, it's a credit. I'm like, sorry, I can't do it. I was like, suckers. No worries. All right, so any questions up to here? Any questions up to here? Okay, so all of this will magically become something. Can everyone see here? Okay, so this is going to be dd theta. I'm going to put a bracket there because brackets look majestic. Bracket. And then it's always your integrating factor times your function, r. In this case, it's r. It doesn't matter which one you put first. I'll go ahead and I'll put the r first. So it's r times, and then our integrating factor, which is the secant plus tangent, right? So it'll be secant theta plus tangent theta parentheses, bracket. And we'll check that in a minute. So all of this, right, magically becomes this always, every single time. It's always your function times your integrating factor. All I remember from last time is we did one, and I was over here, and it was rushed. We had like 2 minutes or something, and we did it in like 2 minutes. It was like, I remember it was really like pressured to finish. And I remember teaching it that night in my night class and thinking like about you all, like, oh, I felt bad for like, oh, you know. But yeah, let's do what Duncan was suggesting. I think this simplifies, right? Secant is what function over what? It's what over what? Do you all?
Over cosine.
1 over cosine. Very good, Kyle. So this is 1 over cosine theta. And then tangent sine over cosine. That one's easy. So I'm just writing it here just so we can kind of like visualize what's going on. So these will cancel. Right? This is going to give us 1. Right? That's 1. Okay, and then this times this is going to cancel the cosines, so it will give us sine theta, right? Sine theta, sine theta. Yep, no mistakes. Look at that. We should check this. I kind of neglected to check it because I just didn't want to do it because I didn't feel like it. You don't have to check it, but you can, so let's do it. It's a little bit harder to check. You can check this using the product rule. Remember, it's the derivative of the first times the second plus the first derivative of the second. So the derivative of the first is, there it is, drd theta. Times the second, oh, must be right? Derivative of the first times the second, see, derivative of the first times the second plus the first. And then here's the tricky part, derivative of the second. The derivative of secant is secant tangent, secant tangent. The derivative of tangent is secant squared, secant squared. So a little bit harder to see that, right? That's why this one is not a good first example to do. That's why we didn't do it last time, right? Because I thought, it's going to be hard to understand this part. Let's check it again. The derivative of the first times the second plus the first, that's your r, times the derivative of this. So the derivative of secant is secant tangent. The derivative of tangent is secant squared, secant squared. So it's harder to check. You don't have to check it. And again, this is the hardest part of the entire problem, right? This right here is knowing this integral. This is the part that, like, what happens if you don't know it? Well, if you're fortunate enough to have like a calculator that has the answer, just type it into your calculator, and I'll believe that you know it, because I have to assume that you have it memorized. Unfortunately, that gives you an unfair advantage if you have one of those, but oh well. Or you can just call it something, like if you don't know what it is, just call it like I, and then just keep going and give me a ridiculous answer, and I will give you as many points as I can for trying. I'll give you more points than if you just quit. But like, oh, you know, like this person just didn't give up no matter what, and even though they got it wrong, you know, yeah. So it's never quit, right? Even if it's bad. Okay, how do we get rid of the dd theta? What do we do to both sides? Do you all remember? What is it? Integrate, integrate, yes, integrate. So I'm going to squeeze it in down here, integrate. You don't have to write it, but I'll write it, integrate. So when you integrate the left-hand side, you just get r, parentheses, secant theta, plus, I was looking in the wrong place. So here, r, secant theta plus tangent theta, I almost messed up, I got lucky, equals, when you integrate 1 with respect to theta, you're just going to get what? Theta. Yeah, theta, very good. So theta. Let's see, integrating sine, that's going to give us, is that cosine or negative cosine? Negative cosine. Yeah, I've messed up here a lot. Negative cosine theta. And then what's missing? Plus c. Don't forget the plus c. What happens if you forget the plus c? It's a -1 or something, right? This is going to be worth probably at least 20 points on your test, a question like this. So you get lots of partial credit, right? So you can do good if you recognize that it's linear, right? If you start it the right way, which you probably will. I believe you will.
I remember you saying that we shouldn't write this down because you'd mark points off for it because it's technically wrong. So what
was I talking about?
Why would you write the integration symbol on?
Oh, I just think it could lead to errors. Because watch this. Let's say I'm doing this. Oh, integrate both sides. If I notice I have to take a point off because you forgot the d theta, right? You have to put a d theta here. That's all. So people forget to do that. So that's all. So plus there's no room. Look, I mean, that's all. That's the only reason I just don't recommend it. Yeah, I never do it in class because I never have room because I always forget about it. I'm too focused on like that step. Good question, Kyle. Yeah, good question. Oh, to finish, we just divide by secant plus tangent, right? So r is equal to, and I guess you could divide each piece of the whole thing. I'll divide the whole thing. Theta minus cosine theta plus c all over secant plus tangent, right? So secant theta plus tangent theta. And that would be the answer. So that's it. That's it. So this is is this an implicit or an explicit solution? Do you remember? Explicit. Good, Zach. No, Trent. It's close. No, not really. But good, Trent. Because we solved for r. Very good. Good, Trent. Yeah, I think it's fill in the blank in the homework possibly. I don't know. Is it like r equals and it has a box? Yeah, perfect. Cool. Good stuff. Any questions on how to get the answer on this one? Any questions at all? We have time. I think we're doing pretty good.
Did we ever figure out what we're calling the y? Because the other one we know is the integration factor. The other one, in this case it's r. Did we ever...
What do you mean, like?
Because we have a nice name for the integration factor.
Oh yeah, this is the integration factor. Oh, what is r? Oh, r is the function we're solving for. Okay. It's the unknown function. Good question. It's the solution. It's actually the general solution to the differential equation. This is all the solutions. Yeah, whenever it's linear, you have all the solutions. It's the general solution to the differential equation. That's what r would be in this case. Yep. And yeah, what's it called when you have a solution that you can't get from this solution? What is it? Anyone know the weird solution that you can't get by picking C? Do you remember what that was? Singular. Very good. The singular solution. Yeah. There's no singular solutions here, right? Therefore, it's called the general solution. Extra life knowledge. Good, Trent. Intelligent. This piece here is going to give us the interval of definition. I'm not going to test you on that because a lot of it's multiple choice in the homework. But let's go ahead and find it. So let's sidetrack for a minute. So we're going to use this to find out the largest interval over which the solution is defined. So I'm going to write it again. Secant theta plus tangent theta. And you want this to be greater than 0, right? You want that to be greater than 0. And then just rewrite it in terms of sine and cosine, right? So secant is 1 over cosine, right? It's the one that starts with the other letter, right? So if it's an S, it's a C. It's a cheap trick, right? If it's cosecant, it's 1 over sine, the other letter. Just a cheap mental trick. And then tangent is sine over cosine. This is pretty sneaky. And we're going to try to find the largest interval over which the solution is defined based on this inequality. So we're just going to solve it using our mind. Hey, Gerardo, right? Yeah, good to see you. Okay, this is 1 plus sine theta over cosine theta greater than 0. So I'll pause here. So we can do that, right? How do I know to do this? Because I don't know how to do it. Like when you see something like this, what can you possibly do, right? Except write it in terms of sine and cosine. Like there is nothing else you could really do. So you just try it and it works. You want this to be positive. Sine, this is always going to be positive unless sine is equal to -1. So let's assume it's not. And so the top is positive and the whole fraction is positive when they're both positive. Cosine is positive between -pi/2 and pi/2. That's one such place where the cosine graph is positive. So this whole thing is positive here. So we'll just pick that one, right? So I think it might be multiple choice. Is it multiple choice? Kim, no, what is your name? Sorry. What is it? Nikki, thanks. I had a K in it, so thank you. So this comes from just thinking about where cosine is positive by looking at the graph, right? By looking at the graph. Again, in the homework, it's multiple choice, and you have 30 tries, so. Yeah, not on the test though, because it'd be kind of hard if I put this on a test, because you can give me all kinds of weird answers, right? And I'd have to mark them right. Because remember, this is a wave function, so like it's positive in other places too, right? So this is not the only answer, right? There's infinitely many solutions. Then we have to find transient terms. Those are terms that approach 0 when theta approaches infinity. That doesn't even make sense in this problem because tangent and secant have vertical asymptotes, so there are no transient terms. So no transient terms in this problem. Should probably do one more of these. probably do one more. This one,
Sorry.
yes.
Could you explain that again?
Absolutely, yes, good. So transient terms are terms that approach 0 when theta approaches infinity. So here, secant and tangent, you can't let theta approach infinity. It doesn't make any sense to because these have vertical asymptotes. So there's no way you can approach infinity. If you had, for example, since you asked, and it's a really good question, Christian, say you had y equals x squared plus e to the x plus 1 over x plus x over ln x plus c over x squared. Just say you had this, just really quickly. Say you had this ridiculous answer to some differential equation, right? I just made it all up. The transient terms, that's not transient, right? That doesn't go to 0. Is that transient? No. What about this one? Yep, because it goes to 0, right? When x goes to infinity, this gets super small, right? It approaches 0. I did it on purpose, accidentally actually. That's really tricky. Is this transient? No, because x grows faster than ln x, right? If I flip it, if I do this, then that would be a transient term, right? I didn't do that on purpose. That was accidentally tricky, but it's good. What about this one? Is it transient? Yep. So transient terms are terms that approach 0 when x goes to infinity. Again, not something I'm going to put on the test or anything. So you just have to solve it on the test. Keep it simple. Just solve. It's more than enough work to have to solve a couple DEs in your 75 minutes of class time in the middle of the day. Maybe you haven't had lunch. I don't know. Make sure you eat and stuff before the test and sleep. Yeah, relax. So it's not till next month, which is actually a few days, but a few weeks. Any questions on this? Okay, let's do something else. Let's do another one. Anyone have one in particular from the homework they had a hard time with? Okay, yeah, you do?
I don't remember the number, but it was something about like solving for y. You couldn't solve for y, so you had to put it in terms of y and x.
Oh, I don't know. Let's see. Was it this section?
Yeah, it was.
Oh, I don't know which one it is because they're all.
Figure it out later.
Okay. Yeah. Yeah, I think you have to solve for y in all of them on this. I'll erase while you look. I'll erase.
Wait. I'm sorry for
Oh, don't. Which part? Which part?
Actually, well, it's still kind of there.
This?
The very first step.
Oh, okay. This. Yeah.
I don't.
How do you get that?
Yeah.
Yeah, good question. So basically, what you do is it's always going to be e to the integral of whatever is here. The formula, I'll use x. The formula is this. If you have this.
And we can just ignore that part.
Yeah, so if you have this is the general formula. So it's really bad handwriting. So this is called the standard form. So whenever it looks like this, you just take that and you do e to the integral of that. So in this case, it's not y though, it's r. So it's tricky. You see it?
Yeah.
Good. What's your name? Austin. Good, Austin. Oh, like this. Never mind.
Wait, like what?
I was like the city, like the wrestlers.
Actually, the city and the movie.
Oh, there's a movie?
One named Austin Powers?
No, maybe it's the wrong guy. Okay, doesn't matter. Okay, isn't there a wrestler named Austin?
Stone Cold Steve Austin.
That's the guy. Yeah, Stone Cold Steve Austin. I don't watch wrestling anymore, but yeah, stopped when I was like, Okay, not nothing wrong with it. Let's do another problem. Did you find one?
No, I was thinking of something different.
Okay, I think I know what you were thinking from 2.2. I think. Yeah, I won't put one of those in the test. Okay, the ones where you have to like make it fit like a certain form.
That's what it was.
Yeah, I'm not going to do that. Don't worry about it. There's too much time. It takes like 20 minutes just to get to that step. Yeah, no worries. All right, let me find one that's decent. I have all the answers here so I can look for one that's like relatively difficult. No, it's boring. No. What can we do that is beneficial and weird? Proofs? Yeah, no. Yeah, I had a friend, he took a graduate level differential equations class. I didn't, and he said it was really crazy. He said it was all proofs. He's like, we don't even solve any DEs. That's what he said, though. I don't know if it's true. I guess I'm just going to have to pick one. I hope I didn't do this one already. Did we do, like number 5? Did we do number 5 last time? Okay, let's just do number 5. Can you read it to me, Nikki? Thank you. No, go ahead. I'm ready. I'm always ready. No. Go.
X y over x plus 6y equals x to the third
I think this one's really simple. So this would be like a good, like, relax, just a test type question, I think. My answer's like this short, so I wrote small, so we'll see. We'll see. All right, nice problem, nice problem. So we have to figure out what to do. So what's the first step? What do we divide everything by in this case? X. Very good, Christian. So step 1 is you make this a 1, right? You make this a 1. And so let's do that. So divide by x, divide by x, divide by x. I'll even divide these little guys by, I'll even separate it like that. I never do that, but let's be different. So dy dx plus. Now, if you remember the formula, this is something that when I had written it down a minute ago because Austin was asking about it. This is the standard form of a linear, right? So when you're rewriting it, you kind of want to make it match this, right? So I'm going to write this as 6 over x times y. So 6 over x times y, just so I can easily identify the big P, right? Just so we can easily use matching. Worth doing. I'm so glad he asked. And this is equal to x cubed over x is going to be x squared, right? X squared, and then minus 1. Yep. So the idea is when you're taking a test, which is so far away, is that you recognize it, right? That you recognize that it's linear. So how do you do that? Just practice, right? Ideally, you finish the homework a couple days before the tests, which is a lot to ask because the homework takes forever because there's so much of it and the problems are long. And then you start just reviewing different types, at random before the exam. Okay, this is your big P, right? So now you just have to compute mu of x, which is equal to e to the integral of big P, so 6 over x dx. 6 over x dx. Do you remember what this was called? This had a name. Do you remember what it was called? The something factor. Integrating factor. Yeah, compute the integrating factor. Integrating factor. I'm going to just do this so it's not super confusing. So this is equal to e, and then 6 over x turns into an ln, right? So it'll be 6 ln of x. Yep, and we still have the absolute value there, right? 6 ln of x, right? Before we can cancel the e, we have to do something with the 6. Do you all remember what it was?
Yeah, one of the log rules.
Yeah, the log rules. You bring it up, right? Yep, I'm glad we're doing it. This is really good. This is a very standard question. I think you'll find that this section is easier than 2.2. Okay. You could, in fact, drop the absolute value at this point because you can actually put the 6 inside the absolute value, right? Anything to the 6th power is going to be positive, provided it's not 0. So this is just absolute value of x to the 6th, which I'm just going to write as x to the 6th. Okay. Any questions? Any questions? I feel like we have a lot of time. I don't know why. It just might not be true, but just in my head, I think we do. Well, yeah, maybe. Actually. Okay. I'm going to write it again. So mu of x is equal to x to the 6th, right? Mu of x is equal to x to the 6th. I'm going to put this in a box. I feel like it's an accomplishment. Like we've made it. We've found something. I think this is going to be a really good test question because of the difficulty level. Like it's something you can do under pressure, but maybe there shouldn't be pressure. So just yeah. Now we have to take this and multiply the entire dE by this. Which one do we multiply? The original or the one we modified and made pretty? No, this one. Yeah, the clean one, the one in standard form, right? So we put an x to the 6th here, we put one here, we put one here. So let's do it. So it would be x to the 6th dy dx. Okay. When you multiply this by x to the 6th, you're going to lose one of the x's, right? So it'll be 6
X to the 5.
X to the 5. Thank you. X to the 5 y, right? X to the 5 y, right? Because what happens here is the x to the 6 cancels with the x, right? So you're left with x to the 5. And then let's go ahead and be pro and just carefully multiply the x to the 6th by both of these terms, right? So let's see, you add the exponents, right? So x to the 8, I believe, x to the 8 minus x to the 6, x to the 6, x to the 6. I like this problem. There's no secant in it. Right? There's no it's all just little x's everywhere. It's great. Any questions? Any questions on this one? So recap. First thing you do, right, is you divide by x. And the reason is you're looking for this form, right? And again, I don't want to make it sound scary, but on an exam, it's a little bit harder. Of course, if you've done all the homework, then this one becomes really easy because the next sections are more challenging. So the goal is to make it look like this. And when you're here, you'll be like, okay, it's linear. I know how to solve it. So it's always e to the integral of whatever is here, okay? Every single time, okay? Every single time, no matter what, okay? And so you just make it look like this, and it's e to the integral of big P. That's going to become an ln. You always pretty much use the power rule. These always cancel. Just always drop the absolute value. It's always the same. Yes, sir?
The integrating factor is e to the what y is being multiplied by.
Yep. It's always, yep. It's always e to the integral of big P of x, so dx. So it's always whatever is here. Yeah, so like let's say, I don't hate to derail too much. Let's say we had plus, sine x y equals 2. Then it would be e to the integral of sine x dx. Yeah. Mm-hmm.
So for the moment, are we always going to be getting e to the natural log of something?
Pretty much. I think, have we ever not? No, yeah. Yeah, there is one somewhere in the homework where you get like e to the x squared as your integrating factor. But that's, it happens. Yeah, usually it's a natural log. So it's usually the same thing. So,
It's just kind of contrived.
yeah, it is. It is totally contrived. It's actually really quite beautiful. I was thinking about it on the way here when I was driving in the rain. Sounds really dramatic, but the fact that this was why does this work, right? It's because someone made it work, right? Whoever created this technique, like worked backwards to rig this to make this work. In particular, this step here is totally contrived. Watch. This is d dx. This is like the step, it's like, what? How did that happen? It's because you work backwards and you make it happen. That's how you come up with this formula, right? I used to do it in class, but it takes like 15 minutes, and I don't know, I just stopped doing it. It's always going to be your function times your integrating factor. So I'll go ahead and put the function first. The function was y. Remember, last time it was r, right? Last time it was r, right? And then our integrating factor is, what would that be in this case? X to the 6, very good. X to the 6, excellent, very good. Pro. And then you have this over here. This stuff is really useful too. Like sure, like this is the class, and you do homework and you take a test and you get a grade and life goes on. But like you do use this stuff, right? If you study partial differential equations, all of the stuff from the first test is more beneficial than anything else, because you take differential equations with partial derivatives and you convert them into differential equations that you're studying now. And so you use all the techniques almost that you learned in this class. When I took PDE, I felt really smart. Because I got to use all the stuff that I learned in this class. I was like, yeah, it feels good. Right? It's like, yeah. It's always fun using stuff you don't learn in class, in another class. How do you get rid of the ddx? What do you do to both sides? Integrate. Yeah, integrate. So I'm going to write it. Okay, I'm actually going to spell it out. Integrate. Yeah, UCF has a couple classes on PDEs. They have PDEs 1, PDEs 2, and there's a second part of this course. So if you go there, it's a good place to continue studying these because that's what a lot of the professors there do for a living. Like that's their job. Like they drive to work every day. They think about like, oh, how am I going to solve that DE? Like that's like their life. Integrating this, we use the power rule, right? What a life, right? Like I mean, right? So x to the 9 over 9. Like imagine that's like your full-time job. Like I've been working on this DE for 3 years. Like minus. Yeah, it kind of sucks though. Like if you don't solve it, there's pressure. Like you get in trouble, you could lose your job. Right? So x to the 9 over 9. Oh, whoa! What's missing? What do we have to add? Plus c. Plus c. Yeah, plus c. Plus c. Yeah, I knew a guy. I won't mention his name because this is on camera, and he did research as an undergrad in DEs, and supposedly he published like 6 or 7 papers. Yeah, he's at Oxford now. He got his PhD in math. We weren't friends or anything though, so he's all right. Really, it's just doesn't matter. To finish, what do we divide everything by? X to the 6. Yeah, x to the 6. So I'm just gonna do it because if I feel like if I show the step, I'm gonna get confused. So when you divide this by x to the 6th, it's x to the 9 over x to the 6. So that's x to the 3rd. Yeah, x to the 3 over 9. It feels really uncomfortable because I didn't show the step. Minus, and then divide this by x to the 6th. X to the 7 over x to the 6th. Is that just x? X? Yeah, okay. I don't know. I guess. And then plus c over x to the 6. That I can handle. So there we are. That's it. That's the general solution. That's the solution to the DE. Solution to the DE.
So on the test, should we write that over x to the 6 for the c?
Yeah. Yeah, just divide everything. Did you see how we divided each piece, Austin?
Yes.
Yeah, good. Yeah, just divide each piece.
I was just wondering if it was like, it's going to be a number,
What is?
like the c.
Right. Oh, you're talking about like how we were combining things last time? You can only combine numbers though. So if it's like c over 2.
Oh, I see.
Yeah. No, good question. Ask. It's good. It's good. So you can't really combine these because it's a variable. God, yes. Yeah, because we made a big deal about that. Renaming stuff. Rename whatever you want. Yeah. Only constants. Only constants. The interval of definition, I guess, comes from here by dividing by x. Basically, x can't be 0. So we have a choice. We can do negative infinity to 0 or 0 to infinity. Let's just go with 0 to infinity. There's no particular reason to pick this one. I just decided to pick it. Right. The only restriction is, well, x has to be, I guess you have an ln here, so x can't be 0. Right? You have an absolute value on it, but just x can't be 0. And then as far as transient terms, let's see, transient terms, are there any transient terms in this case? Yes. The last one, very good. C over x to the 6. And again, not something you'll see in a test. I was thinking maybe I should put it on the test because people will get it right. But no, I don't want to start like, no, it's all right. This first test is already the hardest test, right? So just do your best, right, on this one. So it's the hardest. It only gets easier after this, no matter what I do. Like, even if I try to make the test harder, it doesn't work. It's just because the material, the problems get longer though. Eventually the problems will take, just ridiculous. Any questions on this one? Maybe we should start the next section. So it's kind of an interesting section. We'll do some calculus 3 stuff too. So. All right, let's do it.